Cheaper, cleaner food. That's the goal of version 2 of my AI-powered sprayer drone.
Here you see the drone on an example flight. In the top right's a view of the route it's flying in Mission Planner. In the bottom right, you see the images the camera on the drone is taking of the ground below the drone. It uses a custom image classification model to determine if there's a weed or native grass below the drone, and it turns on a small sprayer to kill the weeds. At the end of the flight, it lands on the landing pad. It's pulled into the battery swap, recharge, and liquid refill station, and a fully recharged battery is inserted. Liquids are refilled, and then it's pushed back onto the landing pad and sent out on another flight. We started this video series with just an overview of the whole drone setup and operation. In the next part, we created the drone, 3D printed it, and set it up so that we could make our initial flight. In the previous video, we created a custom image classification model that runs on that Raspberry Pi and turns on the sprayer when we detect a weed. And in this part, we are going to build the landing pad, automate its operation using a Windows laptop, autoit, and Arduino. So let's go. First thing is to build the charger spinners and their holders. In the first video, we did the drone printing and building, and we also discussed printing the drone charger spinners and the holders that we're using here. So I'm going to assume that you watched that video and you've already printed those parts like we described in that video. So you got them in hand. You start by adding the balance charge ports inside the spinners. So basically you cut thin strips of copper tape and apply them like you see here. The ridges in the 3D printer, in the 3D print, delineate the boundaries between those copper tapes. And there's two different designs. So because you have a charger spinner on the left and a charger spinner on the right, the copper tape pattern is going to be slightly different in left versus right. Here you see the left, and here you see the right. And the reason for this is the charge ports on top of the battery cages are not perfectly centered and identical, so you actually do have to have a left and a right side for this. Then you're going to solder wires onto that copper tape and solder those wires to the balance charge connectors, and make sure you know you've got. We talked about it in the first video, how the battery cage is set up with power, ground, and then the 1S, 2S, 3S battery terminals. So make sure that you match those up. When you're looking at your balance charge connector, it's just going to be the red pin is the high pin, and as you work your way down, it's going to be the 3S, 2S, 1S, and then ground pins. So just sort of makes sense there. You can also see it in this photo. You can insert a battery cage into the spinner and actually test that all the wires make contact. And in other words, that you have the expected voltages showing up when you use your multimeter on those wires. Basically, each cell should be 3.7 to 4.2 volts. So when you go between ground and the 1S cell, you should see 3.7 volts show up. And then again, between 1S and 2S, another 3.7 volts. So that's a real simple way to make sure that you've got all of those connected and in the right order. And once you know you've got that, go ahead and tape up those solder connections so that they don't ever touch each other, as you see here. And then test it with an actual balance charger. So when you insert that battery cage in the spinner, it's just like having the balance charge port connected to the balance charger. And you should see red and green lights turn on your balance charger so that you know that it's actually charging up the batteries. And that's it for the charger spinner. Repeat that 6 times. Next, you're going to set up the holder for that spinner piece. So that was another 3D printed part that we did long ago. And all you have to do here is screw in the servo motor to the charger spinner holster, and then take that little X connection that comes with the servo motor and screw it into the back of that charger spinner. And then it's time to mount this all together. So I took a big piece of plywood, as you see here, set the drone in so that you can get the right position for these things. You just want the charger spinner holster assembly that we were just working on to be pretty tight with the drone, and then screw down those holsters onto the plywood. And it's a tight fit with the drone, but not too tight. Like give it a millimeter of wiggle room so that it can actually push in and out of there without rubbing and getting stuck. Next step is we're going to assemble the arms that are going to push the drone around when it's on the landing pad. You can have 2 5-foot arms and 1 8-foot arm. And each arm is the same thing. It's a 2x2 piece of wood. On one end is a DC motor with a sprocket, and on the other end is just an idler or a roller. And there is number 25 chain connecting that DC motor and sprocket to the roller on the other end. So you're going to start out by cutting an L shape in one end of that 2x2, and you're going to zip tie down the little motor, and you can also attach the sprocket to the motor right now. As long as you're here, you can put a lag screw, just drill a big hole through the 2x2 and sink a long lag screw in there. That's going to be used to like attach this thing to the ground later. So any old screw will do fine here as long as it's pretty big. And then at the other end, you're going to drill that same hole, and you're going to put the lag screw through the roller this time and stick that all on there. The roller should be able to roll freely still. Again, this is going to be used to stick it all to the ground. Then you're going to take some number 25 roller chain, and you are going to connect that motor and sprocket to the roller on the other end. You'll probably need to use a chain break tool so that you can cut the chain at the correct length. You'll just pop out one of the pins, and that'll sever the chain, make it the right length. And then use a master link. It comes with that chain, so attach one of those easy to use master links to reattach the two ends of the chain together at the correct length. So now you'll have your chain is going to be stuck on there, and it's going to be connecting your motor to your roller at the other end. So each one of those arms is the same thing. You have 2 5-foot ones, 1 8-foot one. Now you're going to add something that I've been calling the keeper, but really it's just a little assembly that connects to the roller chain, and it travels up and down the arm. So when the motor's turning, the chain is obviously moving up and down, and this thing's just going to follow the chain. So you start with a piece of 2x2, and you cut 2 little gaps in it. Then for all of the next steps, pre-drill the holes so that you don't split the wood. You're going to add a screw and a metal cover like you see here, and then a wood end, and this is about it goes about 1.5 inches down. And then you're going to take a larger 1/2-inch plywood and stick it to the other side, drilling a hole in that thing so that we can still insert and remove the screw that we previously added. And now you're going to actually add this assembly onto the chain. So all you do is that first screw that we drilled a hole for, you're going to back it out, set this thing over the 2 pieces of the roller chain, use the little metal plate to sort of keep those in place, and then you're going to reinsert that screw until it punches into one of the gaps in your roller chain. So that screw is actually what sort of anchors this thing to the roller chain.
All right, now it's time to start putting everything together. We've just built these charge ports, we've built these arms, and here's how they're laid out. The shorter of the arms go there and there, the long arm goes right here. You do have to sort of I put little runners on here, you can see right over there. There's runners to help that guide across there. One big change is I really should have made this plywood, just 2 sheets of 4x8 plywood laid on the ground. It would make the whole thing a lot smoother. Right now the drone can sort of catch its feet in the tarp, and you don't want that. Plywood would have prevented that. So get those things in the ground. Your lag bolts will actually push into the ground at every corner here and hold that in place. And you're going to line it up so that it, when the drone is pushed fully against this rail right here and then pushed in, it'll land right in this bay right here. And we've sized this bay so that it'll just fit the drone. Next, you can work on these linear actuators. I should have made this an entire 4x8 sheet of plywood, and then I could have just landed these right on the same 4x8 sheet of plywood. Instead, I put these planks on. Don't do that, that was dumb. But the way you know where to place these things is obviously they're in a line, but fully extend this, and the end of it should come to right there. You can actually set a drone with a battery cage in this port right here and fully extend this. It should just barely touch the end of that battery cage when it's fully extended. And then do the same thing over here. Run it all the way out, and when it's fully extended, it'll just barely touch that drone battery cage. That way you know that when it actually pushes a drone battery cage out of there and gets to here, the new battery cage will be inserted into the drone, and the old one will have been pushed out into there. Next up, you've got these 2 relaunch linear actuators. I think I would have liked to make them bigger, maybe 36-inch linear actuators, so that you'd get this thing all the way out into like a very open place out there. But as it is, I had these shorter ones, so I used them. They're pretty simple. Retract them fully and make sure that the ends of the linear actuator are pushed just barely against the leg of the drone when it's in that cage right there. And that, when it's lined up with the battery cage ports over here. So make sure that it can easily pass a battery through there. You can even half insert a battery into it to make sure you've got the drone in the right position. Then set the end of this linear actuator just barely up against that leg. You can see that these are raised slightly up off the ground, and so the foot of the drone will actually sit just under here, right here, and this will be pushed up against the leg of the drone. That way it always pushes against the leg as it's pushing it back out. Next, you're going to place this. It's the reservoir, the water reservoir. I'd like to make it bigger in the next version so that it holds more water. But the two important things to watch out for here are this right here is going to be the output from the pump, and so you need to make sure that it's sitting over the funnel of the drone. This over here is what's going to catch the overflow, so you need to make sure that it's sitting under the overflow tube of the drone. Then just screw the motor down over here and be sure you hook up those vinyl tubes so that they'll sit correctly with the drone in this space. Next, we're going to place all of our electronics over here. We've got a power strip, the 12 and 5 volt power supply, and then 4 electronic speed controllers, and the Arduino. I've also placed these over here. This is the chargers, and you can actually go ahead and hook up those chargers right now to the charge ports that you created on the back of those spinners. So hook those in. And now it's time to actually do the wiring of all this. All these things are screwed in place, but no wires have been laid yet. So starting over here, your supply from the wall is going to come into here. It'll power your laptop, all of those balance chargers, as well as, via this right here, your 12 and 5 volt power supply. Then from here, your 5 volt supply is going to travel out to these servo motors. I just, tied wires under here and then brought it out under wire nuts. I stripped off the ends of some of these simple wires right here. They have those nice pins that'll plug directly into the servo motor ports, and that's an easy way to get the 5 and ground to your servos. And then the 12 volt comes out here to another set of wire nuts, and it goes to every one of these green ports right there. All those get 12 volts coming in. After that, you can work on the motor wiring. You can choose to hook these up to anything you want. I chose to set it to the left battery actuator, this one over here. You can see that I even wrote the pin numbers on there. The next one is the relaunch, this left relaunch motor over here. The next one is the far arm, so that's that guy over there. So that wire actually travels out of there all the way out to here. I wire nutted at this point. There's a super long wire that goes over to there and then to the motor right over there. So it's quite a long wire to power that guy, but I did run it all the way over there. Next is the water. So this right here just hooks up to our pump right over here. After that comes the the long arm. I called it arm 2, but it's this guy right here. So he just travels under this charger spinner and through wire nuts and solder connects to that motor right there. And then we've got the other relaunch. So this goes to this motor right here. This one on the left side of this last electronic speed controller controls this near arm right here. So it actually travels back and around over to here under the charger spinner and to that motor right there. And then the last thing is we've got to control this right battery linear actuator right here. So that's where all of those motor wires go. And the last thing is you've got a bunch of signal wires right here. So I chose to take one port off of the Arduino, plug it into this breadboard up here, and then take the direction port on every one of these. If you're unfamiliar with these electronic speed controllers, you've got a ground here, and then direction, pulse width, direction, pulse width. The first two control the right side of the board. The second two control the left side of the board. Direction just means which direction the motor is going to travel. Pulse width means how much amplitude, how strong does that motor turn on. And so all of those direction pins, so in this case it would be the yellow and blue pin, they're actually tied together in the breadboard up there. All of these direction pins on these electronic speed controllers are tied together on the breadboard, and then a single pin goes to the Arduino to control the direction. And the reason we can do that is each pulse width modulator is connected to a different pin up here. So we only turn on amplitude for one of the motors at a time. The direction does change for all of them, but most of them are getting no signal to actually turn on. Only one of them will turn on at a time. And I did that because I was running out of pins on the Arduino. So you can look at the schematic and see how every one of these pins are lined up. There are names of these pins. So for example, this largest pin 13 over here heads over to there, plugs right in. Every one of those pins connects to the correct place on the electronic speed controller so that it's controlling the motor that I labeled over here in the code that it will actually do what it's supposed to. So make sure you get all those hooked up. And then last you've got A1 and A0 over here. Those are controlling our servos. So the pulse width, that is how wide the pulse is, chooses where the servo position is, which changes which battery is going to be pushed in from each side of this, depending on what comes out of that Arduino. So wire all of that up. and then get your laptop, set it right here, and we're actually going to test all of those things to make sure that they work properly. If one of your motors is going the wrong direction, say that it's trying to retract when really it should be pushing the drone out, all you have to do is reverse the wires that come out of this motor port right here. It will change the direction of it. So you can actually run through all of this and make sure that each one of these motors is activated when it's supposed to be, depending on which part of the sequence it's in, and that it goes the correct direction, so that you will have, arm comes in, water refills, push the battery, and then push the whole thing back out. Make sure that those go in the right order and that you've connected them correctly to your Arduino. So now we're going to hop over and actually look at what we do on this Windows laptop here. We've already loaded our mission planner so that we can load up the code onto the drone, but now we have to automate this whole process, and we're going to use something called autoit. Autoit will control what gets loaded on the drone, and it will actually, through this USB cable right here that comes out of the Arduino, it will load code onto the Arduino that will actually do the gathering process and then the relaunch process of the drone, and it will keep track of which batteries are being charged and which ones we should push in at each step in the process.
Here's how we're going to get this stuff running on our laptop. You go to the Autoit website and you use the Windows installer of Autoit. That automatically associates AU3 files with Autoit, so you can just double-click AU3 files and it'll start running. Next, go to the GitHub for Nathan Builds DIY/drone v2, and the easiest way to get this onto a Windows machine, I think, is just download the zip rather than trying to install Git and cloning it. Just download the zip like you see here. Unzip that somewhere on your Windows laptop, and then you're going to go to the Arduino website, download the zip. I use this version that you see here, and you're going to take that zip file and put it into the GitHub directory that you just downloaded, specifically the drone v2-windows folder. So you're going to put that Arduino zip in there and then extract it, as you see going on here. That gets your Arduino executable into the same place that your Autoit script thinks it should be. Then last, before you get started, you're going to edit the drone.au3 file. I don't know where you put that drone v2-windows directory, and so you're going to have to change the file path so that it matches what's on your laptop. So just do a search. You can see the file paths here. You're just going to search this file and replace the file path so that it points to your drone v2-windows directory. Now you can double click the drone.au3 file and it's going to start running like you see here. It defaults to running in what I call demo mode. It prompts you after each step to click OK before it will go on to the next step. That's demo mode, so that you can actually test out the operations. When you know this thing works, edit that file again and change demo mode to 0, and then the whole thing will run automatically, front to back. So we're going to watch this thing go. This is how you test out the operations of your motors and make sure that everything is in the right order and running in the correct direction. So I'm going to put the PC screen on the left and the actual operation of this thing, physically in the real world, on the right side. First thing, you're going to set the correct path to your first waypoints file that you want to use on the drone. That's like the flight path that the drone is going to take. It'll just cycle through all of the waypoints files that it finds in that directory after it uses the first one. So, whatever your first flight is, enter that into the box here. Upon starting, the program opens up all the Arduino windows that are going to be used during operations. It does that so it doesn't have to wait on opening them later. And then it loads up the do nothing Arduino. That just idles. It blinks an LED while it's waiting for the drone to be landed and do things. So the reason for all these windows is actually there's a separate file for each charger and spinner that's like the servo motor settings. And only the drone.au3 file knows which setting is the next one to be used. So it just calls the correct Arduino setting, and the motors get set correctly. So once all of those files are opened up, it goes right into gathering the drone. There's no waiting here and no clicking a checkbox. It assumes 1, the drone is on the landing pad and it has no battery in it to start. 2, it assumes all the landing pad arms are fully retracted so that it's going to gather the thing in first off. And then 3, it assumes that the first charged battery is on the left side in the 0 position. Now what that means you're going to see here in a second. That's 0 with pulse width modulation going into that. So it's a particular setting of the servo motor on the left side. And you're actually going to get to test out that servo motor setting and see if the charger spinner is positioned correctly so that it'll push the battery in properly here in just a moment. And then you can actually label those. I suggest using a Sharpie and labeling what battery bay is which during the operations of this demo. So It's currently running that drone battery swap v2 start script. And you can see that on the left side, and you can see what it's actually doing on the right side, where it's pulling that thing in. The script uses the arm1, that's what we've labeled it, to pull the drone in tight against the railing, and then it uses arm2 to pull the drone all the way into the battery bay swap area. And then it also does a refill, so it turns on the pump and lets the thing fill up until it overflows. Because we're in demo mode, you now have to click the OK button. It'll go on to the next step, which is going to actually spin the servo motors so that they are in the correct position to get the battery swap going. So you see that here. And then the next thing it does is it goes to the final set of steps. You have to click OK again once that motor is in the right position. And it's actually going to use the arms to push the battery into place. And then it's going to use the relaunch arms to push the drone back out into the launch pad area. And then finally, once it knows that the drone is safe and clear in the launch pad area, it's going to fire up Mission Planner, connect via the radio, load a new set of waypoints, or actually in this case our first set of waypoints, and then tell the drone to move to auto mode, and then arm the drone, and that is what allows it to take off and head out on its mission. And if you've already got your AI working, it will actually start spraying weeds as it flies over the path that you've set for it. That's it. You should run your setup all the way through the demo mode and get bugs worked out the first time. So you might have to flip motor polarities if they're backwards. You probably have to adjust the charger spinner position versus the servo motor so that the battery bays line up. You got to ensure that the motors are turned on at the right time. So in other words, that the signal wires from the Arduino that control pulse width modulation go to the correct ESC for that motor. And then once you've got all of those little hiccups worked out, you can turn off the demo mode and actually run this thing normally. It will use every one of the waypoints files that you have in your waypoints directory, and you can test continual operation and make sure that you can get this thing running smoothly. Let me know what you think in the comments, and don't forget to like and subscribe for more unique and useful do-it-yourself builds.